So differentiating tanx should give you 1 over cos squared x. But before we get to that, let's have a look at our equation. Well, first of all, the tan is not where we want it. It's in the denominator. We need to change it into our numerator. And just in case you thought you'd be using a quotient rule, don't, because 8 is not a function. It is a constant. And so let's rearrange our equation. So first we'll write the 8. And if we want to bring the tan up, we need to make it to the exponent of minus 3. We then write x on 2. So it is simpler if you actually think of the tan to the negative 3 within these yellow brackets here. So now I can write the tan. I'll write the 3 down here. And my only concern is that many of you do not see that x on 2 has a half as a coefficient. So if I was to write this in this form over here, I'm hoping that you might be able to see that. And at this point, we are ready to start differentiating dy dx. So in the first place, we need to see that this is going to be a chain rule. And we need to look at this inside here and need to leave it alone because we're going to differentiate, first of all, what's outside the yellow brackets, which means that we're going to multiply this minus 3, leave the 8 here as well, and just rewrite everything that's in the yellow brackets. So which will be tan a half x. Now we need to now diminish that minus 3 so that it becomes minus 4. And now we're ready to differentiate the tan inside here. This tan is going to be differentiated according to that law over here, where it become 1 over cos squared x. So we differentiated what's outside the brackets. We differentiated the tan x inside, but we also now must differentiate the half x. So what we're going to do is now multiply that by a half. All right, so how can we make this better? Let's multiply the negative 3 with the 8 and then divided by the 2 because these are the constants. So I will have 3 times 8 divided by 2, which will be minus 12. Tan x on 2 to the minus 4. And I also have cos squared x on 2. As mathematicians don't really like a negative exponent, we will move this tan down to the denominator. And once again, as mathematicians do not like to have too many brackets, we can rectify it by putting that 4 up here next to the 10. Okay, I really want to apologize because I went through a lot of steps that are unnecessary here, but which I thought was really important that you understand. Changing those, for instance, brackets and changing that negative exponents to the outside and then back again to the inside, like in here, changing x on 2 to a half x, because sometimes you do not realize it and it's very hard for you if you don't see it as you're differentiating to make sure that you need to also differentiate the half x and take this outside here. If you're pretty good at this now and you do not need to change this, please do it in a shorter form. My intention here is to show you every detail of what you're doing.